Hey students, welcome back. In this video we're going to do Module 5, Topic 4, Proven Triangles Congruent. This is Part 2. It's going to have the same standards as the last video. I'll quickly go over them. GR 1.2, that's Proven Triangle Congruent. We're going to use side, 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 angle, side, angle, side, angle, 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 side. The angle, and hypotenuse leg are going to be later. GR 1.3, we're going to prove relationships and theorems about triangles, solve mathematical and real-world problems involving postulates, relationships, and theorems of triangles. And then GR 1.6 is solve mathematical and real-world problems involving congruence or similarity in two-dimensional figures. Content, the objective for this topic, you guys are going to use ASA and AAS to prove triangle congruence. That's angle, side, angle, and angle, angle, side. We briefly mentioned them in the last video, the last lesson. Didn't do more than that. We're going to talk about them again. The warm-up is on page 14. It's again, Module 5 packet. Please pause here. Try the warm-up. This is concerning the last video. It'll also help with this. Very similar. I'm going to wait 3 seconds. Once you're done, unpause and let's see how you did. Okay, warm up, page 14. Match each pair of triangles with the congruency postulate, which prove that they're congruent. So we got a little word bank for these. So I'm going to put all these that are the same. These are 1 dash, 1 dash, 2 dash, 2 and 2. Should have probably done that before I put the first pencil down. That's okay. I'll do all these the same real quick. Go back with my one here. Let's see. Notice when you can make a bigger angle, you'll see the arc has one of these too. But we do the 2 because it's easier to see when we have such small angles with our stuff. Hang on. See, let's see here. One more minute here. Okay. Now everything's colored in. A little bit easier to see. So number 1. So getting a little tricky here. We just see the 2 sides. We know they're congruent. They're telling us match it up. So 2 sides. It's really tough. We can eliminate these 2 because there definitely can't be 2 angles. So it'd either be side, 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 or side, angle, side. Well, I don't see anything else I'm looking at that we don't know that these are congruent, so we can't mark those. The only angle we're dealing with, if you look in here, these are 2 lines that intersect and make 4 angles. The 2 beside each other would be congruent. The 2 on top of each other would be congruent. So for this one, this angle and this angle are vertical angles, and they are congruent. So we have a side, an angle, and a side, an angle, and a side. Okay. Number 2. So again, we only have 2 here. We have an angle and a side. An angle and a side. So we either need another angle. Well, we need another angle. Right here. These 2 lines intersect. So these are vertical angles and these are vertical angles. Hopefully you guys are starting to see this a little bit on your own. So this guy and this guy are congruent. So now we have an angle, a side, and an angle. An angle, a side, and an angle. All right, number 3. We have 2 sides. So it has to be side, side, side. This guy has 2 angles. So where do we get our third side? Yeah, you've remembered. At least I'm hoping. Yeah, so this guy in the middle, it goes with both triangles, and it is congruent to itself. So number 3 would be side, side, side. And then last but not least, angle, angle, side. Angle, angle, side. Okay. Scooting down page 14. Let's see. Let's just make sure we're good. All right. Page 14. So proving triangles congruent. And this is going to be straight off of the last lesson. I'm going to read it again because it's important. You can prove two triangles congruent by showing that all 6 pairs of corresponding parts are congruent. However, it's possible to prove two triangles congruent using fewer pair of corresponding parts. So again, the corresponding parts. The triangle has 3 sides. The triangle has 3 angles. That's your 6. Okay? So postulate 5.3 again. Angle, 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 side, angle. So let me draw this in. Just a second here. Sorry about that. Goodness. All right. If 2 angles in the included side is between the 2 angles. So if the 2 angles in the included side of one triangle are congruent to the 2 angles in the included side on the second, then those triangles are congruent. Let's see. Yeah, we'll just use orange again. That's fine. If 2 angles in the non-included side, so this is the included side, the side that is in between the 2 angles, either one of these would be the non-included side. So if 2 angles in the non-included side are congruent to 2 angles in the non-included side of another triangle, which it would have to be over there, I shouldn't have done that, then the 2 triangles are congruent. It should be over here. That's me trying to be funny in my own head. Anyway, page 14. Let's flip over to page 15. Okay, page 15. Number 1 at the top left is the I do. Complete the proof. Are given. It says that WX. So WX is parallel to YZ. Parallel is a little, there we go, little arrow in the line, not at the end of it. And that WZ is parallel to YZ. So, and technically, because this is the second line, we would do a second arrow, kind of like the congruent marks to what corresponds with one another. All right. So all those lines are parallel. They want us to prove that triangle WXZ, so this triangle is congruent to YZX, so this triangle. Okay? All right. So first statement, the reasons given. Let's see if you can see let's scoot up. Yeah, so we got the word bank down here. So our first one's given, well, WX parallel to YZ. Okay. Where'd it go? There we go. All right, number 2 is that WZ is parallel to YX, and that was given. Given. Okay. All right, number 3, WXZ. So WXZ, so this is congruent to YZX. So here. So these 2 guys are congruent. What's our reason? Okay, so notice we're dealing with parallel lines. You guys remember back module 3, I think. Inside the parallel lines. So that's interior. These are on opposite sides, or alternate sides. So there'll be alternate interior. Alternate interior angles are congruent. All right, it's going to be like that because we're out of space here. So, and it's down here, so you guys know. All right, so we got those 2. Now, number 4 says the same thing, alternate interior. So inside these lines, these are alternate interior. Notice there's an angle over here and an angle over here. They're on opposite sides as well. Let's see, this angle would be ZXY. Okay, let's see how they've written it. YXZ. Duh, there we go. YXZ, good Lord. YXZ. So this side, poor pencil is just about at it. YXZ and WZX. WZX, yeah. Yeah, sorry, don't know what I was looking at. So, angle YXZ is congruent to angle WZX. That was that one. Okay. All right, number 5 statement is reflexive. Well, my pencil finally died, I think, but let's try it. Yeah. So that line is congruent to itself. This is our first side, so it's just going to be 1. So this is XZ. It's congruent to XZ. And that only leaves that right there, which you see, we've got all sorts of stuff here. But we have an angle, a side, and an angle. An angle, a side, and an angle. Gets a little messy, but there you go. All right, number 2. This is a you-do. Please pause here. Try to work this proof. I'm going to wait 3 seconds, and then I will continue. All right, number 2, write a proof for our givens. So it says BAC. BAC is congruent to DEC. DEC. This says that BD, so BD, this line here, bisects AE. Well, what does it mean by bisect? Hopefully you already remember that if it cuts it into 2 equal pieces. So that means AC is going to be congruent to CE. So even before I get down here, I'm looking at this figure. I'm analyzing and marking this figure according to what they're giving me. Okay? So I see I have 2 out of 3. I also see I have some vertical angles here in the middle. So that's going to come into play too. So before we even go down here, again, and I hope you guys will start looking at it this way. So number 1, BAC is congruent DEC, and that was given. It told us both of those. Number 2, BD bisects AE. That was a given. All right, number 3, statement is blank, but it says definition of a segment bisector. Oh, this bisects here. So AC and EC, maybe? AC and EC? Ha! AC is congruent to EC, and that's because it's a segment bisector. All right, number 4, ACB. ACB is congruent to ECD. So there's where those, that's where our vertical angles are going to come into. And I'll be dog. Vertical angles theorem. It's like I can see the future. All right, number 5. Triangle ACB is congruent to triangle ECD. And how? ACB angle, side, angle. ECD angle, side, angle. All right, number 3 at the bottom. This is the last, I think. Let me make sure. Nope, we got one more page. So yeah, at the bottom here, I think this is a we do, so that means it's a me do. So number 3, complete the flowchart proof. So let's start marking as we go. Our given is RQ is congruent to ST. So the here, and that RQ is parallel. There's your arrows I mentioned earlier. All right, they want us to prove that triangle RUQ is congruent to triangle TUS. Okay, so first one was given, that was that they were parallel. Second one was given, that was that they were congruent. So number 3 down here says vertical angles. The only vertical angles I see are here. This is outside the triangle, and so is this, so it has to be the 2 inside. I know vertical angles are congruent, so let me just go ahead and mark them. So these 2 angles. Now, RUQ and SUT. RUQ and SUT. There we go. RUQ, SUT. All right, we'll go over here. Angle RQS. So RQS is congruent to TS. It says TSQ. Well, yeah, I guess TSQ going all the way down here. So let me mark this. So RQS, so right here, well, let's do 2 because it's the second, is a TSQ. All right, so this one, well, here's our parallel lines. So it's inside our parallel lines and it's on opposite or alternate sides. So we have alternate interior angles. I'm not going to write theorem. I've written enough. So now, how are they congruent? Well, we only have one thing left, but let's just look. So R, U, so now we have an angle, Q. So angle, angle, side. Angle, angle, side. All right, guys. Oh, nope. We got another page. Woohoo. Sorry. Just like you guys right before the bell. All right, top of page 16. We have 3 problems on this page, and that will conclude topic 4. So number 4, page 16. Complete the proof using ASA. So before we even begin, they tell us what we're doing. So here's all these reasons, but they want us to use this one. So we can go ahead and put this in, but we're going to have to prove it. So I'm not going to cross it out yet. I'm going to mark my one arc, my 2 arc. Goodness. 4 pencil. 2 arc and 2 arc. 1 dash, 1 dash. One mark that stuff. Now, our given is that L is congruent to Q. So L and Q, those are your oranges. M and R, M and R, and MN and RS. So there you go. We've already marked it. It's there. Given, given, given. They just boom, boom, boom. Now, this is third angles theorem. We have an angle, 2 angles, so it has to be the 2 remaining angles. And of course, that's what we have left. So angle N is congruent to angle S. And that's the third angles theorem. I mean, doesn't matter about this other side here. This angle, when 2 angles of one triangle are congruent to 2 angles of another, that's the third angles theorem. So now, and it wants us to prove, because it said ASA because it didn't want us to use angle, 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 which we do have a side in there. You're like, okay, well, it's not between these 2. No, but it's between these 2. So you can say angle, side, angle. And that's why it put it that way, because if we'd have started, we would have said angle, angle, side. But it wanted us to use angle, side, angle. So that's why we scooted over. All right, number 5. Complete the proof. So our given DA, so this is a little bit strange of a triangle, as you can tell here. So DAC, so up here, congruent to BEC. So notice this triangle goes this way, this triangle goes this way. All right, but that angle, that's where both of those angles come from. Okay, so those are congruent. That was given. And DC and BC are congruent. So DC, BC. So DC and BC was a given, but we have a second given. That was that angle DAC is congruent to angle BEC. DAC, BEC. All right, we have a given. There's our given. All right, number 3 is blank on both sides. So what do we have to choose from? Exterior angle, alternate exterior angles. We don't really deal with that in triangles, and we don't have any parallel lines. Vertical angles. Here's some vertical angles. So let's see. This would be a, what does it say? Oh, I'm on the wrong page. No wonder those angles didn't look right. All right, so we only have BFA, so we've already used blue. Get this orange over here. So BFA. So is congruent to DFE, so this side. And we know that is true because, so hold on, we have vertical angles. That was the only thing left over there that made any sense because these are all dealing with the triangle. So vertical angles theorem. And the vertical angles, well, the only other choice we had was BFA and DFE. All right, last but not least, how are they congruent? We have all the choices here. So we start, we have A, C, D. So A, C, D, we have a side. Let's see. Oh, no, we started with an angle. I'm sorry, an angle, a side, and then another angle here. So angle, side, angle. I know that one's a little weird. I still don't feel great about it, but I digress. All right, number 6. Bottom of the page. This is it for this particular module. Yellow is, well, I'm going to try one more time with this yellow. Well, I guess, never mind. All right. A company that manufactures windows needs to determine the amount of glass required to make the hexagonal window shown below here. I say that PQ is parallel to TS, so PQ, TS, parallel. That R is the midpoint of PT. So if R is in the middle, then PR and TR are congruent. So I know this before I start. Here's our word bank. Determine whether triangle PRQ is congruent to TRS. So because PQ is parallel to TS, so those are marked, RPQ, and RTS, wait a minute. RPQ and RTS. So yeah, these two angles. So RPQ and RTS because of the blank theorem. Alternate exterior, well, they're not outside the parallel line, so that's out. But they are vertical angles. Wait, no. Wait, this is wrong. Because it's not vertical angles. Vertical angles would be here and here. These are alternate interior. They're inside, but and they're all alternate. So that's a typo. My bad. Alternate interior angles. Okay. Because point R is the midpoint of PT. See, PR. PR. Congruent to R. Well, TR. Okay. By the midpoint theorem. And TRS, oh, here we go with the vertical angles. TRS, oops, PRS. And so the other vertical to this, so TRS, it would be PRQ. PRQ. Our vertical angles, so they're congruent by the vertical angles theorem. Therefore, by blank, PRQ is congruent to TRS. So we have an angle, a side, and an angle. An angle, a side, and an angle. An angle, a side, and an angle. All right, guys, that is it for this. If you have any questions, let me know in class or send me a message on Teams or in Focus. Until next time, have a good night.